Target number 8, looking at calculating the volume of a cylinder. So we've looked at rectangular prisms, triangular prisms, and now we're looking at cylinders to wrap up how we take a look at volume. So let's review a couple things. First of all, when we're looking at a circle, we've got radius, which is going from the center of where we're going out to the edge. That is our radius. When we're looking at diameter, that is going from one side all the way across to the other side. So now that we've got our radius and diameter, another quick review down here is that our area of a circle is pi times r, or pi times r squared. Remembering that r squared is not r times 2. Not, I think this is red, not r times 2. R squared is r times r. Okay, so let's look down at an example. Let's see. So we've got our area of our base times height. That's our general volume equation. So for the volume, the area of a circle is pi times r squared. So we're going to multiply that by the height. So again, we're using 3.14. We're not going to use the whole pi. You can if you've memorized it. You can if you have the pi button on a calculator, you want to use that. We are just going to use 3.14. We're going to simplify things slightly for today. So 3.14 times, we have our radius. So our radius right here from the center to the outside of the arc is 8 centimeters. So 3.14 times 8 times 8 times 11, which is our height. Okay, and all together that's 2,210.56 centimeters cubed. Remembering, as we've always said before, that the area of a base is in something squared, centimeters, meters, whatever, kilometers, and the height is something just in that. So when we multiply those all together, they equal centimeters cubed for volume. Whoop, a little messy, but you know, you're used to it. So let's take a look at some practice. So a group of researchers drilled into a glacier to get a core sample of ice. So we're drilling in, we're looking for what's in the ice, finding out lots of neat things about what was in the ice thousands of years ago when the ice froze. This isn't like ice in your backyard. This would be like glacial ice that's been frozen for hundreds or thousands or tens of thousands of years. The hole from the cylinder that they left behind was 2 meters wide and 73 meters deep. You would not want to fall down that. You think like Timmy fell down the well. 2 meters wide, that's like as tall as I am. So we've got this monster hole in the ice. 73 meters deep, 2 meters wide. Okay, so the distance across that circle is 2 meters. That is our diameter. Okay, and you can imagine just a little circle on the bottom there too. And 73 meters deep. This is how big this hole was that they left behind. So if this is the size of the hole, it's 2 meters across. It's circular because drills are circular. It's 73 meters deep. How much ice did they take out? What is all of this? What is the volume of all of this ice that they took out, that massive chunk? How would they even move that chunk? I don't know. This is an interesting question. 73 meters, you'd need like a lot of semi-trucks to carry that around. So, added an extra E. All right, so let's take a look at this. So we've got, let's scroll back up and just double check. There's our equation. Volume equals pi times r squared times h. Okay, now that you got your equation, let's see what we can do. So we've got pi is 3.14 times, what's our radius? Well, we know our diameter is 2. Scroll back up. Oh my gosh. How do we figure out our radius from our diameter? Diameter equals radius times 2, or radius equals diameter divided by 2. Okay, we're good there. We can keep going. So, if our radius is 2 times 1 times 1, oof, interesting. Okay, so now we're going to go 3.14 times 1 times 1 times 73. Times 1, is that going to do anything? No, it's not really going to change anything. So we can type into our calculation devices 3.14 times 73, and that's going to give us 229.22. Now, what are we in here? We are in meters. Meters, and because we're calculating out the volume, it's going to be meters cubed. That is a massive chunk of ice. So does that make sense? Hopefully. If it doesn't, send me a message. Let's look at a couple more examples to see if that helps. We've got here, again, our formula, volume equals pi times r squared times h. So let's give her a shot. Let's switch colors just for something different. How about green? Volume equals pi r squared times h. So we'll put her in. We know pi is 3.14. Here we've got our radius, middle to the outside, is 15 times 15 times 15. You could also write that 15 squared, but for the sake of how we're doing it, we're going to go like that, times height of 6. Then we're going to type that all into our calculation devices. 3.14 times 15 times 15 times 6 equals 4,239. What are we in? Centimeters cubed. Okie dokie. So let's scroll into the next one. We've got our same thing, except instead of up, like a pie, it's down, like, I don't know, something that's down. So like a tin can that you're rolling a golf ball into. So volume equals pi times r squared times height. Now this one, height is kind of crazy. This looks a little different. Height in this case, if you remember, just like our triangular prisms, the distance between the two triangles was the height. Here, the distance between the two circles is the height. Okay, so pi, we can actually not write it as pi this time. We can write it as 3.14 times, again, we have our diameter is 10. So let's just go over here. Diameter or we want radius equals diameter divided by 2. So 10 divided by 2 equals 5. So we're going to use 5 as our radius. 5 times 5 times our height is 20. Okay, again, into our devices. 3.14 times 5 times 5 times 20 equals 1,570 centimeters cubed. Okay, let's roll down and look at this one. Okay, so switch that to the wrong side. That's okay. So looking at this one, I'll leave that here. Pause this video, read it, and then solve it on your own before you hit play again. I'll wait. Okay, hopefully you unpaused it. You're good to go. Here, let's roll. I was going to wait for a just excruciating long period of time, but I'll hold off on you. Pi volume equals pi r squared times h. Let's just put that in there so we're ready to go. A manufacturer produces a can with a height of 7 centimeters and a diameter all the way across of 5 centimeters. How much soup can this can hold? So if you filled this entire thing all the way up to the top, you didn't leave like a little bit of space or anything like that, you filled it all the way up to the top, what are we at? So I'm going to switch back to blue because I just really like blue. So we're going to figure out the entire volume of this can, okay? So volume, we're going to use our same equation, 3.14 times, oh, what's this radius? We know that radius equals diameter divided by 2. And so we've got 5 divided by 2 equals, that's right, 2.5. Okay, so times 2.5 times 2.5, because that's what our radius is going to be. Half of 5 is 2.5, times our height of 7. So into the machine, 3.14 times 2.5 times 2.5 times 7 equals, oh, we got a few decimal spots. We can assume that we're only going to use 2. So we're going to go 137 point. Now I have 375. So we can put the 3. And if I wanted to round that, am I going to go with a 7 or am I going to go with an 8? 0.375. The 5 is 5 or up. So I'm going to round it up to 3.8. So 137.38. What is our units? Centimeters. Centimeters. Cubed, squared, single, cubed. Excellent. So that's it. Taking a look through our word problems and our regular problems with our volume of a cylinder, pi times r times squared, just don't get caught up with your diameter, times the height. Again, the height is the distance between the two circles. So work through the questions. Let me know if you have any problems. Take care of yourselves. We miss you. We're thinking about you, and we'll see you again soon.